Hello friends, welcome to my channel Learning Electronics. In this video we are going to learn about zero crossing detector and its working. So before starting the video, please subscribe my channel and also press the bell icon so that you can get more updated videos from here. We have already studied about the comparator circuit, and we know that in the comparator there are two inputs. One is we apply signal voltage, another input is known reference voltage. So when we make the reference voltage is equal to 0 in the comparator circuit, so the comparator circuit will become zero crossing detector circuit. So zero crossing detector is also a basic comparator circuit with zero reference voltage. It is used to detect sine wave transition from positive to negative when input crosses from zero voltage condition. That means it is used to find sine wave zero voltage point, and it is a sine wave to square wave converter. Zero crossing detector is used to control the AC switch. Next one is types of zero crossing detector. There are two types. One is inverting zero crossing detector and another one is non-inverting zero crossing detector. In the inverting zero crossing detector, the signal voltage or input voltage is applied at the inverting terminal, and the non-inverting terminal is grounded to make reference voltage is equal to 0. Now we find out the cases to draw the output waveform of the inverting zero crossing detector. First case is when input voltage is smaller than 0, we have output voltage is equal to plus V saturation or plus VCC. So let us see how this we got. Input differential voltage Vd from the circuit is V2 minus V1. Here V2 is equal to V reference is equal to 0 and V1 is equal to V in. So we get Vd is equal to V reference minus V in. Since V reference is 0, we get Vd is equal to 0 minus V in. So here we can see that V in is smaller than 0, that means negative. So we get Vd is equal to positive. Negative, negative, positive we get. Now output voltage is equal to open loop gain into Vd. So output voltage is equal to positive. Since Vd is positive, so output voltage will go to plus V saturation. Second condition, when Vin is greater than 0, output voltage is equal to minus V saturation or minus VCC. Because Vd is equal to V2 minus V1 and Vd is equal to V reference minus Vin. Now V reference is 0, so we get Vd is equal to 0 minus Vin. Here we are seeing that Vin is greater than 0, that means Vin is positive. So Vd will be negative. Therefore V out will be, output voltage will be negative, and we got V out is equal to minus V saturation. Now we are going to draw output waveform for these conditions which we have found out. So this is the reference voltage. Since it is 0, so it is on the x-axis. This is the signal voltage. So first we find out the reference voltage and signal voltage intersection points, then we project those points on the output voltage x-axis and we draw the waveform. So here we are seeing that from point 1 to point 2, V in is greater than 0. That means V in is greater than V reference. So for this we have output voltage is equal to minus V saturation. So here we have minus V saturation. Similarly, from point 2 to point 3, V in is smaller than 0. Output voltage is plus V saturation. So here we have plus V saturation. And beyond point 3 we have V in greater than 0. So we have output voltage minus V saturation. So in this way we can draw the output waveform. So here we are seeing that the sine wave is converted into square wave. Next is transfer characteristics for inverting zero crossing detector when V reference is equal to 0 volt. This is V reference 0 voltage point. So we have conditions when V in smaller than 0, we have plus V saturation output voltage, and when V in greater than 0, we have output voltage minus V saturation. So these are the transfer characteristics. Next one is non-inverting zero crossing detector. In this, the signal voltage or input voltage is applied to the non-inverting terminal and the inverting terminal is grounded to make the reference voltage 0. Now again we find out the conditions for V reference is equal to 0 volt. When V in smaller than 0, we have output voltage is equal to minus V saturation or minus VCC. So from the circuit Vd is equal to V2 minus V1, here V2 is equal to V in and V1 is equal to 0. So we get Vd is equal to V in minus 0. Since Vin is smaller than 0, we get Vd is equal to negative. Therefore, output voltage will also be negative and it will go to minus V saturation. Second condition is when Vin greater than 0, we have output voltage plus V saturation or plus VCC. Again, we find out Vd is equal to V2 minus V1. We have Vd is equal to Vin minus 0 since V1 is 0 here. So, we get Vd is equal to positive since Vin is greater than 0. So, output voltage will also be positive. So, output voltage is equal to plus V saturation. Now, we draw the output waveform. This is the signal waveform and this is the reference voltage which is equal to 0. So, we find out the intersection points for reference voltage and signal voltage and we project those intersection points on the output voltage x-axis and we draw the output waveform based on these conditions. So, here we are seeing from point 1 to point 2, Vin is greater than V reference. So, we have output voltage plus V saturation. So, we got plus saturation here. Similarly, from point 2 to point 3, Vin is smaller than 0. We have output voltage minus V saturation. So, we have minus V saturation here. Similarly, from point 3 and above, we have Vin greater than 0. So, we get output voltage plus V saturation. So, in this way, we can draw output waveform. So, here also sine wave is converted into square wave. Next one is transfer characteristics for non-inverting zero crossing detector at V reference is equal to 0. So, this is the V reference is equal to 0 point. We apply the conditions. When V in greater than 0, we have output voltage plus V saturation, and when V in smaller than 0, we have output voltage minus V saturation. So, these are the transfer characteristics. Last one is applications. First, zero crossing detector can be used as frequency counter. Second, it can be used for switching purposes in power electronics. Third, it can be used as phase meter. So, these are the applications of zero crossing detector. Hope you have understood the topic. Thank you very much for watching and please do subscribe my channel for more updates.